By 2020, the scaling laws from the last lecture had a consequence nobody had ordered. As the models grew, they began to do things they were never explicitly trained to do. Show GPT-3 2 or 3 examples of a task inside the prompt. No retraining, no new dataset, and it continues the pattern. This is in-context learning. Ask it a question in plain language, and it answers the question instead of merely continuing your text. These abilities were not designed in, they appeared with scale. In 2022, they were given a name: emergent abilities, capabilities that are absent in small models and show up, sometimes abruptly, once a model crosses a certain size. This is also the moment the money arrived. The last lecture left scaling laws as a forecast: spend more compute, get a predictably better model. Emergent abilities turned that forecast into a business plan.
As they say, it's better to show than to tell. So let's do a demo about emerging properties so we know what we're talking about. I'm going to be using a simple model, a small model called Ministral, Ministral, which is a large language model, but it's a small one. It's a small model that you can run in your computer, the 3B. I'm going to be using the 14B in the Ollama application. It's really simple to use, and you can run a large language model in your computer. In this case, it's a 14 billion parameter model. I can say hello, and it's going to answer really fast. So I'm going to show you the emerging properties of large language models in this model that you would be like a state-of-the-art model in 2022. Okay, first of all, the first ability is the ability to follow instructions. I tell him to classify reviews, and it's going to do it for me, no problem. Look, that is going to be able to classify and follow instructions and do what we ask of the model. This is really important because before we had this emerging property, if you wanted to have a model, a machine learning model that did what we wanted, we needed to train it. We needed to do actual neural network training with a big data set and all of the knowledge that is required to do the actual training, all the algebra, all the algorithms, and a lot of decisions. And it could go wrong, and the capabilities of the model are really limited. But then we just have that. We can have models doing what we ask them to do. For instance, let me ask him to do reverse the sentence, and it's going to do what we ask. So suddenly a machine learning project stops being just let's go and learn a lot of things about neural networks and algebra and stuff, and just prompt correctly a model, and the model is going to follow instructions. So that's really interesting. And then there's this kind of training. If I want the large language model to acquire new capabilities, I don't need again to train the model. I just can, what they say, train it in the context, just by providing, just in this case, for instance, how to route the packages in a company. I provide some examples of how to route things, and the model is going to answer correctly. I don't need to train the large language model for my company. I just prompt it correctly. I put the information, I put the rules in the context, and it's going to learn it automatically. So that's why sometimes people say, maybe incorrectly, that they are training LLM while they're doing just RAG or just doing prompting, because the outcome is as if they have actually trained the model just by providing the model with a prompt. So right now we have that without having to know a lot of information. Now we have the ability to make the model behave as we want without just using the prompting interface, just by using in a clever way the context. And then we have another interesting, really interesting if we are developers, abilities that the model can write in structured outputs. In this case, for instance, JSON. I can tell him extract people, dates, and all amounts of from the text and respond only with valid JSON, no pros, using the keys people, dates, and amounts for each of the listings. And okay, I have this JSON that I can copy. And I can go to my terminal. I can do just pv paste, which this is going to do the clipboard. My clipboard is going to send it to the command JQ, which is a formatter for command line interface formatter for JSON, and I just execute this, and there I have well formatted JSON output by a really fast model that is running in my computer. So this is crazy. I can even push it a little bit, and I can say, okay, I'm going to provide you with an empty array, and then I understand that if it has to extract text and people and there's no data to extract, it's going to provide me correctly with an empty JSON array. So it's incredible. Then, to make things more interesting, the large language models, as you know, if you have used Copilot or something like that, these models are able to write code. These models are able to write code. So it's really fast. In my computer, with a small model, I can have a model that writes code, and then I can copy it. I can go to my terminal, and I can do like example PyPy. I can paste the context. I can do and the code sort of runs, and we have an error at some point of the code, but it's pretty good for that small model that we are using. So let me and then we can use another emerging properties is that we can use a large language model for things like using different languages. We can use Catalan even with a really small model, and then I can even mix models. And I can even mix languages in what I do. I can, this is a paste problem, but I can use this example, and then I can mix English with Spanish, and it's going to mix English, French, and Spanish in the same message. And this is something that nobody was expecting. They were training a model in French, and it will reply in French. You train a model in English, it replies in English. But if you train a model in French and in English, it can mix, it can translate, and it can even follow instructions. This small Mistral model, it's able to, you ask it to answer in French, in English, you provide it with an example in Spanish, and doesn't have any problem mixing all the information. So now we have all of these emerging properties mean that most of the work that we have been doing before by training neural networks, now just by cleverly using large language models, we can solve the same problems. And since, as we're going to learn, we can use a large language model via an API or a CURL, a web service call, then you can build applications and build these emerging properties inside your applications. We will continue.
If capability is a function of compute, and more capability keeps unlocking new things the model can do, then capability is something you can buy. That is the engine underneath the generative AI investment surge of the last few years. But here is the part that changes your job. The last lecture showed you half of a shift. Instead of hand-building features for a task, you took a pre-trained model and fine-tuned it. Emergent abilities complete that shift. For a large class of tasks, you no longer train anything at all. Sorting tickets, classifying emails, pulling fields out of a document, that used to be a project. Gather a labeled dataset, train a network, tune it, and start again when the task changed. Now you describe the task to a general model, in plain words, and it does it. The low-level machine learning project becomes a prompt, and that is why a new discipline appears. If the way you get a model to do what you want is by describing it well, then describing it well becomes engineering, with techniques, with failure modes, with moves that reliably work and moves that reliably don't. It is called prompt engineering, and we will spend real time on it in the next lecture.